earlier, Arslan, who's the other workshop host, he taught some of the basics that would have been a good foundation before like this workshop. But I think you might be okay. You should be okay. Yeah. I'll do my best to explain concepts. And if you have any questions or having trouble following along, please maybe hop on your mic and let me know. Or if you can type in the chat, I hope I can see that on the side of my screen. Yes.
Okay, so just to clear things up, sorry, I wasn't here earlier. For the last lesson, I had something else I had to do. I was having trouble with all this and stuff like that. But I on my iPad right now because I currently don't have a PC available to me. I think we're like getting one or something. I'm not sure. Is it okay if I do it on my iPad today?
I don't think you're able to install Python on your iPad. You might be able to use Replit.
Okay.
Yeah, so Replit is another kind of compiler, but it's online, so it might run on an iPad. I'm not exactly sure about that. You might want to try it out because I'll be using like Python compiler, but if someone could help you out with that.
Okay, thank you.
Cool, yeah. Mm-hmm. Nice, thank you, Hannah.
The workshops should also be posted on our YouTube channel afterwards. So when you do have access to a PC, a laptop, whatever, you guys can rewatch the video and follow along.
I don't think I can use Replit. I don't know.
That's okay. Yeah. So our lessons will all be available to you on YouTube. So there'll be a video recording on YouTube, and you'll see our lesson plans attached in your hack pack. Yes, that's what it's called. So no worries. Right now, you can just follow along, ask questions as we go, and then later on, if you can have access to something that does work, feel free to ask us questions then, and we will help you out.
Okay, thank you.
Sound good? Of course. Okay, so I think almost everyone is starting to come in right now. I will paste our, yes, that is your code to check in. Make sure you do check in. That gets you 10 points, which is really cool. And hopefully you're registered. If you aren't registered, you can do that so that it appears in your events you're registered for list, and then you can check in. And then upon checking in, you should have access to our lesson plan in case you want to follow along yourself with the lesson. And if you would prefer to just follow along with my screen share, that is also very cool. I checked in for part 1. That is just for the part 1 workshop. That's separate from the part 2 workshop. So you would check in twice.
Where do I check in?
It's on the 7-week challenge website. Yes.
Okay. Okay. So
you
is
should
it
find that within your events? Would you mind repeating that, please?
Oh, I got it. Okay.
Perfect.
Thank you.
Nicely done.
Okay.
Okay. I think that's
just to quickly clarify, we changed it last minute. So if you guys already checked in for Arslan's workshop or the Programming 101 workshop before, that's the same event. So if you guys already checked in with the code, you don't have to check in again. But for anyone who didn't catch the code in the previous workshop or just forgot to, or if you guys didn't attend the first part, please use the check-in code on your 7-week challenge dashboard to get your points for attending this workshop. Thanks, guys.
Cool. Thank you for clarifying. Nice. So follow Lily. Yeah. Is that clear? We can put Python 520. I am teaching from, well, now until like 5:10. Yeah, not sure what's happening at 5:20. Probably something exciting. Have fun with that, whatever it is. Okay, I feel like it's a good time to start now. I'm gonna hit record. Record on this computer. I think it's this computer. Yes. Cool. And then I will share my screen. Yes, I can share my entire screen. Okay, everyone can see this okay? Is there a way I can watch the chat on the side? I'm gonna assume that this is okay because I can't see the chat. So we're gonna start, and if something's going wrong, please stop me. Okay, so in part 2 of our Python workshop, we're going to go through lists, list comprehension, dictionaries, functions, and recursion. Starting off with lists, you want to make sure that you assign your list to a variable using square brackets. So we can follow the example here. We have our list name, square brackets, and that defines your list. You don't want to make your list variable just list because you see that it changes colors, and that means that it is a built-in function, which will break if you try to set it to something else. Okay. If you want to create a list with stuff already in it, you put values within your brackets. So you can see if we have our list name, and we can add in number, like integers, floats, strings, or any other type if you feel like it. And that works. Elements in a list are identified with indexes starting with 0 because in computer science we start counting at 0, just like if you're counting your indexes in a string. So if you had your string as hello, if you did print s at 0, you would get your h. And if you made your list s equals to h. I see 3 more from, okay. Oh, there is a chat. Cool. Is there a way for me to see this? That's going fine. Okay. H-E-L-L. That looks fine. If you printed S at 0 again, you would also get an H back. Okay. And here are an entire list of functions that you can use when manipulating lists or working with them. You can use this throughout your challenge to help you out if you want to do stuff with a list. It is cool. Let's see if you wanted to append an item. So let's define our list as just an empty list. And then if you wanted to add something, list name dot append, like let's add a 0. Print. Wow, there's a 0 in it now. Cool. And again, make sure that you define your list before you start trying to add to it, or else it doesn't know where it's looking. For example, if you wanted to, let's pretend we had a list named nums.append 4. It breaks because our list hasn't been defined yet. If you want to remove an element from the end, you use .pop. You can actually also add an index between the round brackets if you want to take out something that's not from the end. So if we did, we're going to add multiple elements here. List set to a variable list equals list name dot pop. And that gives us our last element, but we could also do n is equal to list name dot pop from the first spot, and then you get the 0. What .pop also does is it takes it out. So if you printed list name now, you get only 1, 2, and 3. Okay, I'm gonna make some extra space. Okay. Now you can do deleting items from a list using multiple ways depending on what you're trying to take out. So if you wanted to delete, we're going to keep using list name at 0 again. If you printed out your list name, now you only have your elements 2 and 3. For deleting, you have to put an actual index between the brackets. Unlike pop, you can leave it either empty and it'll take out the last element, or you can put in an index for a specific spot. I'm going to start a new shell because this is really okay. Cool. If you wanted to remove an actual item from a list, we're going to just make a new list now. New. 0, 1, 2, 3. You can take out, let's say we wanted to take out the 0, so new list dot and it takes out the 0. But you have to make sure that your element is actually within your list, because if you remove something that's not actually there, again, it gets lost and doesn't know what to do. So if we wanted to remove like a 6, it goes, oh no, don't see that, and therefore I break. You can find indexes of things within your list. So if you wanted to find the position of a specific element you're looking for, you can do position is equal to new list dot index. We can look for the 4. And then if we printed out our position, we find out that our item 4 is at position 3. If it isn't found, then we wanted to just put directly new list dot index 10. It breaks because our 10 is not in the list. Cool. And the last function I'm going to introduce to you guys is finding the length of a list. This also works for strings. Yes. If you wanted the length of new list, you end up with the number of elements within your new list. Something to kind of watch out for here is if you had a list of strings, so string list equal to okay, and you printed out the length of your string list, it only gives you the number of elements within your list, not the number of characters here, unlike if you did the length of a word. Because this counts the actual characters. Okay, I'm going to do this example with you to utilize the stuff that we learned. There we go. Okay, so let's say you're playing hot potato with your friends and you're like super competitive, you want to win, and make sure that you're sitting at the right spot. We're going to create a program that helps you decide where the optimal seating position is. So what you want to do is first find the number of friends that you have. So we're going to set that as a variable n equals to your integer input. And this is number of friends, not including you. Okay. And then we want to make a list of all the players that are involved. So I'm going to name that players is equal to my empty list. I can define it, and then I can start adding people to it. So I'm going to use a for loop. And we're going to use n plus 1, because if you have n friends, then n plus 1 is the number of people playing. I'm going to add add a comment here. Okay, and then we're going to append their position. And the reason why we use I+1 here is because if I just use this kind of a loop of for loop without a starting position, it starts at 0. So this will add 1, 2, 3 instead of just 0, 1, 2. Now with our player setup, we can start at our position 0. And that would be where player 1 is sitting. Equals. Okay. Where. And we're going to use a while loop. The reason why we use a while loop is because we don't know how many players there are at the very beginning. It's just our n+1 number. And we want to keep playing until there's only one person left. So I will use while the length of players, which would be the number of players remaining, is greater than 1. We continue looping through. So for J10, you move your position by 1. And then we're going to mod this by the length of players. We do this so that you don't go out of range. Otherwise, you're going to end up at a position that's not within your list and Python breaks. We want to print the person that's getting taken out. We want to delete them because they lost. And then we mod it again in case they're at the last position. If we take that person out, then our current place is actually not an index that is good for your current list. Okay, and after looping through that, you'll have the winning position. So we're going to print the is players at 0. And players at 0 would be the only person left in your list after looping through. Okay. Is that okay with everybody? Seems like
Yes.
it. We're going to keep going. Thank you very much, whoever replied. That was very nice of you. Okay. Moving on with list comprehension. We're going to go back to our shell, or actually I can run a new Python shell. Okay. Take this out so that we have a clean slate. Okay. So list comprehension is kind of like a shortcut to fill up a list with either empty values or a bunch of values that are the same, so that you can fill them throughout your program. So we can show how this would work. List. So we're going to do an empty list for I in range 10. And this would give you a list of 10 empty lists. Wow, so cool. Okay. And then if you want to do a list of zeros because you're trying to count something, you can do we're going to spell it like that. Okay. And there you have your 5 zeros. This is like condensing a for loop that you would have to use to add a bunch of values in, because you're putting your for loop within your list, and that makes it list comprehension. And we're going to do our last example there, list of if you wanted to print this out, wow, great shortcut to get 100 hellos all at once. So what can you do with the list of lists for this? You can append something to a list contained within it. So you can specifically pick out list of lists. If you wanted to add something to the first list here, this first empty list, you would specify your position so that your list at 0, and then you would append to it, append. Now if we print our list of lists, we now have a value within our first list. If you wanted to take it out, you would use 2 indexes, because you need to specify which empty list it's in, so it'd be at position 0, and then which item you're trying to take out. So that's the item at position 0, and there you get your value. Okay, what can you do with your second value, with a list of empty, just a bunch of zeros? You can change values within that list. So if you wanted to do list of 0, did I spell it thing? Okay, at 0, if I wanted to add 1 to that, now you've got a 1 there. Okay. And then to retrieve a value from this, it's the same as retrieving a value from a 1D list. You could do 0 at, we're going to go with like 2 this time, because why not? And you get a 0 because the item at position 2, 0, 1, 2 is a 0. Okay, changing values within lists. There are several ways to do this. You can do it 1 by 1. So if you had a list of numbers, and if you wanted to change the value at position 1, you'd say nums at, or position 0, sorry, position 0 is equal to whatever your new value wants to be. Let's make it a 6. And it's swapped out. You could also use another kind of like your list comprehension thing. So if you want to double every value in this, it's n times 2, or n in nums. And what this does is it loops through each item in nums and multiplies it by 2. This is a condensed version of using an entire for loop with multiple lines. So if you printed out your double nums now, each item is now multiplied by 2. Cool. If you wanted to divide by 2, you would do this, but instead of a multiplication, you would use division. And then if you wanted to do like string manipulation using the list comprehension stuff, you can make a new list called words filled with strings. New words. Cool. Okay. And you can also create like boundaries. So you're only performing an operation if it satisfies a condition. So using our nums list again. Oopsies. Okay, yeah, nums is that. And then if we wanted to only multiply by 2 if the value was even, you add your condition here, if n mod 2 is equal to 0, which means that there's no remainder if you divide by 2. Nice. And you see you don't include this because it doesn't satisfy this condition, and therefore it doesn't want it. Okay. We're going to do this as an example. Go back to this. This is good. I can actually just comment this out instead of deleting it in case you don't want to see it afterwards. Okay. So you're working at the store and you have an interesting manager who really likes even numbers. And she also really doesn't like when you do things inefficiently. So she's going to ask you to make a code that takes out all the odd values from a list of numbers that she's given you. We learned from before that we can take our input and split it immediately in our first line. So there we go. We already got straight from our input to our number list in one line. Now we only got 4 left. Okay. We want to only keep their even values, which means that we know we want to use like a condition and something that's like the list comprehension thing that we used, because that is a condensed version of a multiple line for loop. Because this splits it into strings and not integers, that means that we have to convert our value into an integer before we start comparing it to other integers or nums, because we're going through each value in this. If, and our condition, if our value mod 2 has no remainder. There's one line. Now we have 2 lines total. We've got 1 more left. We want to print out our even values. And this should work. Oh, okay. We're going to restart our shell. Let's say we had a 1, 2, 3, 4, 5. We only keep the 2 and 4. Our manager is now very happy and we probably get a bonus check. Cool. Any problems with this so far?
No.
Thank you. Good to know that one person is doing fine. Okay. And now we continue through to dictionaries. This is like a list, but kind of fancy because in lists, you are limited to your keys being just the index values. But with dictionaries, I'm going to put this back over here. With dictionaries, you're able to use whatever value you like as your key. Okay. So like lists, you want to define it before you start using it. But unlike lists, you can actually use dictionary as your variable. Nice. If you wanted to add a value, you would have to specify the key and the value that it's associated with. So if we want to add apple as a fruit, dictionary at apple is fruit. And if we wanted to print our dictionary at apple now, oopsies, we should get that. Okay, we get fruit. And you can also mix values, which is really cool. If you wanted to do dictionary at 0 is a string. You get a string, or you get the value that the key was at. Okay, we're going to do this example to utilize dictionaries. comment this out too. So you are a fantastic grandchild and are trying to help your grandfather figure out where stuff is in a superstore because he can't read the signs. So we're going to make a dictionary. Oh, that's a lot of, okay. Apple is in fruit. I'm going to do when vegetable and when fruit. But if you feel like it, you can do all of them just as good practice. He'll type in what he's looking for. So if he types in apple, he'll get fruit aisle. If he types in broccoli, he'll get vegetable aisle. We want to print it, our input to be space aisle. And else. Cool. Okay. Let's run this. See if our grandfather can find his stuff. We type in apple. Get the fruit aisle. Wow, he's not lost anymore. Do we have time to do a little extra? Okay, we're gonna add a little twist on this because most people aren't going into the grocery store for just one item. So we're gonna make this a for loop. Let's make it a for loop. Your grandfather has a maximum of 3 items. We take in his input. If it's in the dictionary, we print out the item. Otherwise, you print out that it's not on the list. And this way, he can type in multiple things as he likes. Apple, fruit aisle, broccoli, vegetable aisle. And you can keep going for up to 3 items. Okay. Continuing through. For functions, did we pass? Isn't there a break in the middle of this? There is at, I think, 4:20. Cool. Okay, we can do functions hopefully in 10 minutes. Okay, to create a function, you start with the word keyword def. We're going to make a function in this instead of the shell because then we can have a little more space. Okay. So let's do the say hello function. So we do def in lowercase letters, the title of your function, and then what you want it to do. So we're going to just do print hello. And if you want to use your function, you would have to call it. So here we can just do say hello because within our function, we're printing something. Run this, print hello. Usually though, it's actually better to return a value within your function. So instead of saying print hello, you would say return hello. Because what return does is it exits your function and gives you back a value instead of doing something for you. So you say print hello. And it does the same thing, but this is definitely a better habit to have. Instead of printing stuff within your function, you return your value and then you print it outside of your function. Variables are a tricky thing with functions because if you declare it within a function, it doesn't exist outside of it unless you make it global. Otherwise, it's just like a local variable. So if we had we're going to do define v as short for define variables. You try to print any of these outside. Let's say if you wanted to print my string. Oh no, it's not, it doesn't exist because it's all hidden inside of this function. But if you tried to print it within the function and then you called your function, it does find it because it has it within your function. This is not a good habit to have. Make sure that you don't start defining random stuff in your functions, or else you'll try to call it outside and wonder why it's broken. This is why we have parameters. You put your parameters between these round parenthesis brackets, yes. And that way you can use it throughout your function. And if you return it, you can call your function somewhere else. Let's pick a number, 8. It gives you 9. And this is good formatting because that's why you don't have global and local variables everywhere. You just have your parameter, you use your parameter, you return it, and then you can use it outside of your function. If you wanted to have this value to work with outside of your function, you can set it to a variable. So num is equal to add 1 8. And then if you printed your you still have 9. To emphasize this again, return is a keyword that tells Python what to give back. So here, putting return there means that my function is done. I have a value that I want to give back to the user so that they can work with it afterwards. So if we did this, it would still only add 1 to your number because it doesn't even get this far. It gives you 9, not 10. Cool. We can do this as well to use different if statements too. You're going to use your mark as your parameter. If your mark is greater than 80, return nice. You don't need the round parentheses here for your return values, so that's good to know. Okay. And you can use elif here, but you don't need to, because if your mark was already greater than 80, you would exit your function at this line, which means that we can just keep using if statements instead. Equal to 50. And then if you don't make it anywhere there, you did your best. And let's say you got 52. You passed. Nice. If you wanted to use ELF here, you would have to set more boundaries. Because otherwise, it doesn't recognize that each thing is unique. Equal to 80. Also, you passed. Okay. Feel like we can take it. It's 10 minutes. Yes, 10 minutes here, and then we can come back to take up this problem together. If you feel like it, you can work on this throughout your break. But I encourage you to relax, chill. You know, computer science is a little stressful, so rewind, and then we'll be back in at 4:30. That sounds right. Yes. I think that's the schedule. Okay. How do I go back to this? No. Oh, yeah, okay. So I'm reading your questions now. I use for k in range instead of for j in range because it's not a good habit to use the same variable for multiple things within the same program, because oftentimes Python will get mixed up, not knowing whether to use the k from before or the k from afterwards. It also makes things a lot more clear to yourself when you're coding, so you don't get things messed up. Mhm. Yeah, of course. Sure thing, yeah. Go ahead. I'm free for however long this break is, yes. If you'd like, you may hop on your mic if that works better for you, or if you're more comfortable with the chat, that is also great, yeah.
The mic would work a lot better, yeah. So you know how you put the if and then you put the return? So since if you use the return, it doesn't, you can use if for the next statement as well. If you were to have, if you put print instead of return underneath the if statement, then would that, could you also put, like if you put if, sorry, just wait, instead of elif, if you put if again, would it still work or would it just not work?
That's a very good question. Let's see what that does. So you're saying if I put print here?
Yeah.
And if I just did if here?
Yeah.
And do I leave the return here, or would you like me to switch this to a print as well?
I think print.
Okay. I'll change this mark to something that's within that range. So let's do 81 first. This is nice, and you did your best. Wonder why that is. Okay, so here we have two different outputs because at this print before, it doesn't actually exit the function. So it continues looking through for other things that it satisfies or until you get to a return. So the 81 satisfies this first if statement. Your mark is greater than 80, so it prints your nice. It's not between 70 or 80, so it skips that. It's not between 50 or 70, so it skips that. And then it sees this return you did your best. When it sees that, it realizes that technically you're still part of in the function. It works, and so it'll output that as well because you printed it here at the bottom.
Oh, okay, that makes sense. Thank you.
And just to make this, if you did return here instead, you wouldn't get this last bit at the bottom. It would only print out your nice because you're exiting your function at that return value. That was a good question. Yes, please bring up any cases that you aren't sure of, because then we can look at them together and discover what the answer is for ourselves. Yeah.
What would happen if you used else for the return of the last one?
I know that in Java it'll get upset with you, but we'll see what it does in Python. Okay, we're gonna go with a different. Let's go with the 49. Does work because the else works the same as if you didn't have it there, because this is your last resort, just going straight for this. The else takes care of any other case that doesn't fit into these first three. But you don't need it, because if it's not in the first three, it's going to end up down here anyways.
Thank you.
Thanks. Oh, I should probably have the chat open on the side. Does it not want to be there? Okay. Chances are we might have some extra time at the end if recursion goes well. So we'll have time to go through maybe a couple of extra examples if y'all are down for that. Or I welcome any questions about anything that happened before for clarification. Really, ask any question related to Python and I will do my best to clarify. Okay. I hope everyone enjoyed that 10-minute break of doing nothing. Okay. We're going to take up this question. If you tried it out, that's great. If not, also cool. We're going to do it together. Okay. Oh, wow. Okay. So, polar pandemic, you can't see people in person. So you have to send a digital hello to every single one at an online store. That is a lot of work and you don't want to do it. So you're going to make a program to do it for you. Okay, so we're going to take in a customer's name. Your input. And then you're going to output a nice welcome message. So we're going to make our function def. I actually like making my functions before anything happens. It doesn't exactly matter where you put it as long as it's somewhere before you start doing stuff with it. So def and for name. And we're going to return. Instead of printing it out within our function, we're going to return a value and print it outside of our function. So return welcome. Space there. Plus their name. And I'm going to add an exclamation mark because this is exciting stuff. Okay. Think of a name. I hope if there's someone named Jeff here, hello, welcome to the digital store, Jeff. Cool. Because it feels like we have some good time, we can actually make this more realistic because usually it's not going to be just like one person going into a place at a time. It's going to be multiple people. So let's say our input is multiple names at once. So we check our input and we split it. And now we've got our list of names. And then instead of only doing one name at a time, we can use our for loop here. For name and great name. I don't know. Okay, here we go. Jeff and them. And this can go on for as many as you put in your first input. Okay. And now onto our last topic, recursion. It's like a function, but kind of fancy. The concept of recursion is a little interesting, but once you get the hang of it, you'll be great. Okay. In recursion, for this function, you need a base case, and the function has to call itself and move towards your base case. I don't know why these indents are so big. Okay. Let that out. Give ourselves some extra space. So this is our Fibonacci sequence. We know our Fibonacci sequence is 1, 1, 2. I hope this is right. 1, 1, 2, 3, 2. That's 5. 5 plus 3 is 8. That's like 13 or something. Okay. If we define this as fib, because I don't know how to spell Fibonacci. If your n value, so if this would be like your position within this pattern. So if your position is less than or equal to 2, because when you're counting positions in a pattern, you don't really start at 0. You start at 1, 2, 3, 4, 5, and so on. So if your position is less than or equal to 2, you would return 1 because the value in both of these positions is 1. Otherwise, you have to add the 2 preceding values. So you return and this would be the position 1 placed before it and the position 2 placed before it. And we're going to comment this as. So So if we printed out Fibonacci sequence at position 5, what's that? That's 1, 2, 3, 4, 5. Oh, it'd give us 5. Okay, there you go. Nice. And what this does is, let's say you're at position 5. Okay. At position 5, because it's not less than or equal to 2, it goes to this else statement, and I'll see, okay, I have to add the 2 preceding values. So that would give me position 4. And position 3. So with position 4, it sees that it's not less than or equal to 2. So at position 4, which means that goes to the else statement, and it will add position 3 and position 2. Three. It sees that it's not less than or equal to 2. So it's position 2 and 1. But here, we notice that we know position 2 and 1. Because position 2 and 1 were both the value 1. So here it goes back to position 3 as, I'm just going to do P2 and P1 now. P1. This is P, this is just 1 because it's less than or equal to 2. And then it goes to 2 is 1, and then position 1 is 1. And so now we've gotten ourselves all the way to this base case. And with these values, it starts here and starts working back up to position 5. It'll continuously add everything together because we're returning our values, the sum of our values, until it gets back up to position 5. Because we know position 4 is these 2 positions added together. We know position 3 is these 2 positions added together. And then position 3 is these 2 places, and position 2 is this value. And then we continue going down until we get to our base case and then work our way back up. And that gives us position 5 as 5. Okay, if there's any confusion surrounding this, hopefully after working with it a while, it kind of becomes clear. Or if you have like a specific question, I will do my best to explain it better. Okay. We have this last problem to look at. So factorials are another kind of example where recursion is used. You work at a factory that produces items based on the day. So somehow if you're at like day 100, you can create 100 factorial items. Here we have a small definition for how factorials work. Okay, I'm gonna make this. We're gonna define our factorial function. We're going to make our parameter the day. Yes, that makes sense. And then we need to make our base case. So if our day is the first day, then we know that we're supposed to return 1 because 1 factorial is 1. Otherwise, we're supposed to return your current day multiplied by that factorial of the day that comes before it. And after, we're going to kind of trace how this works to help make it clearer. Yeah. Let's pick a day. We're going to pick 6 because it's the sample input factorial. Woohoo, got 720. Nice. And let's trace this. Let's say you're on day what? We're going to actually trace our current example. You're on day 6. 6 factorial is equal to 6 times 5 factorial. Because it sees that 6 factorial, 6 is not 1, and so it'll return your 6 times the factorial of 6 minus 1, which is 5. Then it sees the 5 factorial. It doesn't know the value of that yet, so it says 5 factorial is equal to 5 times 4 factorial. Then with 4 factorial, it sees it's 3 times 2 factorial, and then you get to 2 factorial, where you do know the value, 2 times, and then 1 factorial is 1. And similar to our previous example, it'll go all the way down to the base case, find the value, and then slowly work its way up, because we know what 1 factorial is. You can find 2 factorial. With 2 factorial, you can find 3 factorial, and so on until it works its way back up to 6 factorial. That's all I have to teach y'all. Please, I welcome any questions or clarification. If you guys want another example for a specific topic, I'm totally down to take one up. How do I bring the chat back? Okay. Otherwise, we can spend the next period of time working with the concepts within this lesson so that you're fluent in them for your challenge tomorrow and for the rest of the week. Yeah.
I have a question.
Mm-hmm.
When you use the definition function and then you put, for example, when you put definition factorial in brackets n,
Oh, here, yes.
why do you always use n? Is like just like a is just like what you picked, or is like do you have to use n every time?
That's a good question. I do use n because it's convenient. You don't have to use that variable. If I made this like number, or even if I made this day, it's my parameter variable so that I can work with it throughout my function. So this would still work.
Oh, okay, I see. Thank you.
Yes, it does work. It's a good habit to pick variables that are clear, and so you understand them when you look back. I pick n for number because spelling out number is too long, and so is num. Yeah. It is going to be on YouTube, and there will also be a recording available to you in case you want to review any concepts. And both Arsalan and I will be available this week to answer any questions, to provide guidance, and help you all out. Does anybody have any examples they'd like me to go over? If they made up their own question, or I am down to try and answer it. Of course. Oh, that's a good question. Okay, we're gonna look at that. So I use this. It's the modulus operation. Yeah, okay. We can actually review operations if y'all would like. So if you had, let's pretend. If you had 4 and then you wanted to divide it by 2, that divides evenly, yes. But then if you had 5 divided by 2, that doesn't divide evenly, so you'd have 2 with a remainder of 1. What modulus does is it finds you this remainder. So we can do this in our shell. 4 mod 2. Zero, but then 5 mod 2 gives you 1. Okay. And then do you have to use can you just add a space? May I ask where I'm looking for? Oh, is it this?
Yes, and I said that by accident to direct message, so nobody's gonna know what you're talking about.
Oh, that's okay. Yeah, no worries. So Serena is asking if I have to use this. This is just like a side note. It's not really code. I actually don't know if this would do anything if you try to use it in a actual program. This is showing like the direction of thought. So for position 5, we're looking at position 4 and 3. And then position 4 and 3 leads to these two positions, because in our Fibonacci sequence, in our Fibonacci sequence, I'm going to try to spell it. Fibonacci. That looks right to me. 1, 1, 2, 3, 5, 8. At position 5, it's the sum of these two values. But because Python doesn't know what those values are, it has to keep looking farther down until it gets to our base case. And this isn't really code. It's like a note thing. Yeah. I wonder what it does in code. Let's see. Try it. 5 minus greater than 3. Oh, yeah, okay. It's invalid. Darn. It would have been really cool if it did something fancy.
Okay, thank you.
Yep. Would we like to go over operations or any like if else statements? Like we can you yes, you can power. We can do this in shell as well. Power is a double multiplication, so if you do 5, we're going to do square because 25, and it's 2 of like the little stars, because you have 5 times 2, and then you have 5 to the power of 2. Nice. Of course, yeah. Thank you, and thank you for participating. It's great to see a lot of y'all are into these workshops. Makes us feel good. Any other operations y'all are curious about or do root? So a root is, there is actually, if you imported math, I think there is a square root function, but this is what I like to do because I don't want to import stuff. A square root of like, let me pick 25 is also equal to 5 to the power of a half. So if we looked at this in the shell, open a new shell that's clean. You get 5. Sure, you're welcome. Anything else? We've got another 10 minutes to go. You can ask questions about this workshop, the previous workshop, any curiosities you have about Python in general. I will hope that I know how to do it. Yeah. Otherwise, I'll just be here for the next couple of minutes. Split. Okay, yeah. Can we do this in shell? Yes, we can. So split takes your input and it'll take it apart at all the spaces. I think you can also split based on different characters if you want to. So we have our values is equal to your input. Oh, I should probably do this in a separate thing here. Okay, values is equal to your input dot split. So if you had 1 space 2, if you see they're all separated by spaces, so dot split would separate there. Yeah, sure thing. Okay, and you'll get your list of values split at the spaces. notice how these are all like strings and not integers, because your input has to remain a string for it to actually split properly. I think you could also split if I tried this. Does that want to work? Okay. Why is it printing a 5? Where is the 5 coming from? Oh, okay. Nope, doesn't want to get spaced out. So if I had a bunch of things like 1, 2, it does. So you are able to split based on a specific character, and if you want to split based on like a commas, you could use input.split at comma, and you would insert the character that you want to split at. Will we be using libraries eventually? I'm not particularly sure about that. If you would like to use more like in-depth material, there are multiple resources for you to use. And if you would like us to guide you through that, we are available to do that as well. But libraries is not covered in the intro to Python course. Maybe later on, if it's necessary. Mm-hmm. Oh, okay. Would we like to do a quick review on loops? I'm just going to start doing one. Okay. So there are multiple types of loops here, specifically for loops, I think. Yeah, okay, we're going to do for loops specifically. Okay. For loops are used when you know how many times you want to loop through, compared to like a while loop that goes on forever until you meet a certain condition. So for range, if you put only a single value here, you start at position 0 and go all the way up to, but not including your value here. If you do put a starting position, it is inclusive for this, but non-inclusive for the second spot. And see how you go from 1 to 9, including the 1. You can also add a third parameter, which is the interval you want to count at. So instead of adding just 1 each time, because usually it's assumed that this third parameter is 1, you're adding 2 each time. So you go 1, 3, 5, 7, and 9. You can also use for loops to go through a list or characters in a string. So if you have a list of values, you would have, oh, that prints out the first part too. Okay, we're going to take this out. You have your 1, 2, 3, 4, 5. You could also use for the I thing as well, for I length of values, and then print values at I. And that also works. It just depends on if you want to manipulate something at a position, it's best to use a for I in range loop. If you just want to go through the values without manipulating anything, you can use for item within your loop or within your list. Yeah. Does the third number addition or multiplication? Oh, yes. Okay. So Serena, I think, is talking about if we had like 1, 10, and 2. Okay.
Yeah.
Nice. So what this third parameter does is it's your counting interval. If it's not there, if it's just a 1 and 10, it is assumed that you're counting by 1. If it's not, if it is there and you want it to count by like 3s or 2s, you can change it so that it counts by 3. So you see,
Okay.
you start at 1, then go to 4, and then 7.
So like if you would want it to go by like multiples of 2, you would have to start at 0. Like the first number would have to be 0, so then it would count by
Yes.
2s. Oh, okay. Gotcha. Okay, thank you.
Sure thing. And you would have to specify this, otherwise it's counting backwards. Oh, yeah, actually, that brings up a good point. You can actually count backwards with this too. So if you're starting at 10, going to 1, and you want to count by, like, make this work. Yes, you can count backwards by 2s. And every value here needs to be an integer. It doesn't like floats or strings because you can't add a string to an integer. Yeah. Why does it include the when you run it? Because when it looks at your range, we're not using IJ. For this first value, it is, oopsies, it's inclusive, so it'll always include your starting value. But the second one is non-inclusive, so it won't include your 10. It only goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9. Oh, wow. Okay. Yeah. Yeah. If there's any last minute questions. Oh, also, if there's any review things that you would like to go over, that's also cool. They can be from anything. And I hope I have the knowledge to cover it. Yeah. Are you using Replit for the challenge? I think Replit should work for your challenge because you're able to save your code. It might be a better idea if you can install Python and have the files directly on your laptop. So in case like your Wi-Fi goes out or something bad happens, at least you can still code, in the dark. Yeah. Well, Replit should be okay if you can't access like a Python compiler directly. I also think you have the entire week to work on the challenge. Yeah, so be creative with it and do your best. Yeah. Where will the challenge be posted? The organizers, yes, they're taking care of the challenge and like where it's going to be posted. All the workshop people did is we wrote it. Yeah. It should be in the Discord channel, I believe. I think Lily might have a better idea of where it'd be. Perfect. Thank you. Mhm. And with the challenge, it's like open, like book. Yeah, so you can ask any of the workshop hosts or use your hack pack to help you out. If there aren't any last questions, I think it is a good time to let y'all go, so you can get ready for David's workshop in the afternoon. That should be exciting. Very fun. Yes. Okay. Goodbye.